Hello friends, you are welcome in the lecture of refrigeration and refrigerate. So these are the content. So if the main purpose of the machine is to cool some object, the machine is named as refrigerator. So the machine which cools some object, that is called as a refrigerator. If the main purpose of machine is to heat a medium warmer than the surrounding, the machine is termed as a heat pump. So these terms, they are used in the HVAC. So it is the process of providing and maintaining a temperature well below that of the surrounding atmosphere. That is called as a refrigeration. In other words, refrigeration is the process of cooling substance, a process where heat is transferred from a lower to a higher temperature level by doing work on a system. Refrigeration is the process of removing heat from substance or space to reduce its temperature and transferring that heat to another substance. Refrigeration is providing and maintaining the temperature below that of the surrounding temperature. Okay, so these are the various definitions of the refrigeration. So where this refrigeration it is used? Generally the growth of a food destroying microorganism is quite fast at 10 degrees centigrade than at the temperature lower than 4 degrees centigrade. In order to preserve the fruits, vegetables, fish, meat, milk, medicine, etc. against spoilage at higher temperature, generally during summer season, the use of refrigerator is very much emphasized. The storage of perishable products at low temperature greatly reduces the activity of both the enzymes and microorganisms. Mostly these refrigeration or refrigerators, they are used in industries like chemical industry, pharmaceutical industry for separating and liquefying the gases. Okay. So it is used in manufacturing and storing the ice for preservation of perishable food items in cold storages. This is used in the agriculture field for cooling water, for controlling humidity of air, manufacture and heat treatment of the steels. So again, the humidity, it is also important in the textile industries for chilling the oil to remove wax in oil refineries, for the preservation of tablets and medicines in the pharmaceutical industries, for the preservation of blood tissues, etc. For comfort, air conditioning in hospital, theaters, then commercial complexes as well as domestic purposes. So these are the various applications of refrigerations. Basic refrigeration methods. There are many means to obtain a refrigeration effect, but only the three basic methods are: first is mechanical refrigeration, vapor compression system, absorption refrigeration system, steam jet or ejector system. So all these three methods use similar process for obtaining the refrigeration effect. Evaporation in the evaporator, where heat is absorbed from the space. Condensation in the condenser, where the heat is rejected to the environment. And expansion in a flow restrictor. So in this refrigeration system, the refrigerant is used to transfer the heat from the evaporator by evaporating, means the liquid refrigerant is converted into the vapor form. So during this, it will absorb the heat from this space. Then this vapor, it is sent to the condenser where it converts from vapor form to the liquid form, and during this it rejects the heat gain from the evaporator to the atmosphere, and again it is passed through this expansion wall, and there is a continuous flow of this refrigerant, so which will maintain the effect of this refrigeration. So there are some basic terms. Refrigerating effect N. So it is the defined as the quantity of a heat extracted from a cold body or space to be cooled in a given time, and it is denoted by N. So it is a ratio of heat extracted from the cold space to the time taken. Then specific heat of water and ice. So it is the quantity of a heat required to raise or lower the temperature of 1 kg of water or ice through 1 Kelvin or 1 degree centigrade in 1 second. So specific heat of water CPW is equal to 4.19 kilojoule per kg Kelvin. So with there are some basic terms like melting or fusion of ice, freezing or solidification, vaporization, condensation, sensible heat, latent heat, specific heat or specific heat capacity, then specific enthalpy, then saturation temperature, saturation pressure, superheating, subcooling. So these various terms you learn in your high school. Then capacity of a refrigeration unit. It is defined as the quantity of heat extracted from a cold body or space to be cooled in a given time. The capacity of a refrigerating unit is expressed by their cooling capacity. The standard unit used for expressing the capacity of a refrigerating unit is ton of refrigeration. So 1 ton of refrigeration is defined as the quantity of heat abstracted to freeze 1 ton of water into 1 ton of ice in a duration of 24 hours at 0 degree centigrade. So 1 ton of refrigeration, which is equal to 336 kilojoule multiplied by 1000 kilojoule divided by 24 hours, and it becomes to 33.333 kilojoules per minute or 3.8889 kilojoule per second. The next is a coefficient of performance, COP. It is defined as the ratio of a heat extracted in a given time to the work in. So this coefficient of performance is equal to heat extracted in evaporator divided by work input, or refrigerating effect divided by work input, which is equal to N upon W. And this COP, coefficient of performance, is always greater than 1 and known as theoretical coefficient of performance. So as told that in the refrigeration system, some gas or liquid, it is used as a refrigerant. So any substance that absorbs heat through expansion and vaporization process and losses heat due to the condensation in a refrigeration process is called refrigerant. Okay. So some examples of refrigerants are ammonia, NH3, carbon dioxide, CO2, sulfur dioxide, SO2, freon 12, methyl chloride, methylene chloride. So these are the various refrigerants they are used in the refrigeration system. Apart from this, there are many more refrigerants. They are used as a refrigerant in refrigeration plant or in the air conditioning system, okay, or in HVAC application. So these refrigerants again, it is absorb heat through the expansion and vaporization process and losses heat due to the condensation in a refrigeration process is called refrigerant. Okay, so these refrigerants, they are classified as primary refrigerants and the secondary refrigerant. So primary refrigerants, it is a working medium which is used for cooling the substance by absorption of the latent heat. Ammonia, carbon dioxide, sulfur dioxide, freon 12. So these are the examples of primary refrigerant. Secondary refrigerants is a substance already cooled by primary refrigerant and then employed for the cooling purpose. Example, ice, solid carbon dioxide. So these are the examples of secondary refrigerant. These refrigerants cool the substance by absorption of their sensible heat. So types of refrigerators: ice refrigerator, air refrigerator, and vapor refrigerator. Ice refrigerators, ice is kept in the cabinet of refrigerator and this act as the refrigerating means. Air refrigerators. Air is used as a working agent in this type of refrigerator. Example, Bell-Coleman cycle. Vapor refrigerators. The working agents employed in this type of refrigerators are ammonia, CO2, SO2, and freon. The properties of the refrigerators. The refrigerators must have the following properties. A good refrigerant should have high latent heat of vaporization. It should have low boiling and low freezing point. Then it should be non-toxic and should non-corrosive. It should be non-flammable and non-explosive. It should have high thermal conductivity. It should be easy to handle. It should have low specific volume of vapor. It should have high coefficient of performance, COP. Low boiling point and low freezing point because they are working at the minimum temperature, okay, so that it must absorb the heat from the cold medium. So that's why it must have low boiling point so it absorbs the heat from the area to be cooled. Then when there is a leakage of these refrigerants, so it must be non-toxic for the environment as well as the human health. It should non-corrosive when it is moving or passing through the metallic tube, so there should not be corrosion. Non-flammable or non-explosive. In case of leakage, it must be non-flammable or non-explosive. Then high thermal conductivity. So when it is passing through this metal tube or it absorbs the heat and this heat is carried out in the condenser, so it must have the high thermal conductivity and it should be easy to handle. So these properties must have by the refrigerants. Refrigeration system consists of these main components. First is evaporator, compressor, condenser or heat exchanger, expansion device or the throttling valve, and receiver. So these evaporators, they are inside the refrigerators from where the liquid is converted into vapors by absorbing the heat. Then this vapor, it is compressed by the compressor, so that there are low pressure and high pressure are generated by using this compressor. Then condensers, the high pressure vapor compressed by this compressor, it is passed to the condenser, and this high pressure vapor with the higher temperature than the atmosphere or the surrounding. So the heat is dissipated to the atmosphere, and this vapor again it is converted into the liquid form, and it is collected in the receiver, and this liquid again it is passed through this expansion device or this throttling valve from high pressure to low pressure. In this expansion valve, the diameter is more than this capillary at this condenser side or at this receiver side, so that the diameter is expanded, so the refrigerant is converted at the low pressure. So these are the main components in the refrigeration system or in the refrigerator. Now we discuss about the vapor compression cycle. So in this diagram, so various components as discussed in the previous slide, they are shown. This is a evaporator, compressor, condenser and expansion valve. So this evaporator, so it absorbs the heat from the surrounding or the cold refrigerated space. So in this evaporator, when this refrigerant it enters, so it is in the liquid form. It is in the liquid form. And to convert this liquid into the vapor form, so the thermodynamics of the vapor compression cycle that we analyzed here on the temperature versus entropy diagram. Okay, so here there is a temperature and here there is a entropy, specific entropy and this temperature. So at this point number 1, here we start from this saturated vapor. So this liquid, it is converted into the vapor form, and for this conversion of this vapor, so it absorbs the surrounding heat. So at this point number 1, so it is a saturated vapor. So it is a saturated vapor. So this circulating refrigerant in the form of vapor, it enters the compressor as a saturated vapor. Okay, so we can see here at the output of this evaporator there is a saturated vapor, and this saturated vapor of refrigerant it passes or it enters in the compressor. Okay, it enters in the compressor. So this phase number 1 to 2, it is a compression of vapor. It is a compression of vapor with the help of this compressor, and here we are providing the input work on the compressor with the help of electrical energy. So from point 1 to point 2, the vapor is isentropically compressed. Here the vapor is isentropically compressed, that is compressed at the constant entropy. So here there is a vertical line. Here there is a vertical line. Okay, means the entropy, specific entropy, it is constant. Specific entropy, it is constant. So at this constant entropy, this saturated vapor is compressed by the compressor, and it exits the compressor as a superheated vapor. Superheated vapor. Okay, so because it is compressed by the pressure, by the compressor, so the temperature is increased. The temperature is increased from the saturated vapor to the superheated vapor. Right? So this is the superheated vapor at this temperature, say T1, and at this constant uh, specific entropy it is compressed, so that the temperature of this vapor it is increased and it becomes a dry type. So this is a superheated vapor. Okay, so the temperature is increased. Now at this point 2 to point 3, okay, so it travels from point 2 to point 3 on this entropy versus temperature curve. So the vapor travels through the part of the condenser. Okay, so in this part from 2 to 3, so it passes through the condenser. It passes through the condenser from 2 to 3. So during this condenser, it removes the superheat by cooling the vapor. By cooling the vapor. Okay, means जब it removes this higher temperature or it dissipates this higher temperature to the atmosphere. So the heat always flows from higher temperature to the lower temperature. And in this condenser, the heat is removed or heat is dissipated to the atmosphere. Okay, and the vapor is cooled down. Now from this point 3 to point 4, between this point 3 to point 4, the vapor travels through the remainder of the condenser. And so अभी condenser का जो बाकी जो portion है, in that portion, so this vapor it travels, okay, and it convert from vapor to the saturated liquid, and it converts in the vapor to liquid form. So condensed into the saturated liquid, and the condensation process occurs at the essentially constant pressure. Okay, so it occurs at the constant pressure. Now between this point number 4 to 5, so this liquid it is collected in the receiver. Now between point number 4 to 5, or here between point number 3 to 4, so this saturated liquid refrigerant it passes through the expansion wall. Okay, so here the vapor it is converted into the liquid form or into the saturated liquid form, and this liquid refrigerant it passes from this expansion wall. So in this, during this expansion wall, it undergoes an abrupt decrease in the pressure. So this expansion wall, evaporator, and up to the compressor, this portion is a low pressure portion. And with the help of this expansion wall, so from this small capillary tube, the diameter of this evaporator or this tubing in the evaporator, it is more, so that the pressure is dropped, and here the low pressure is absorbed by the refrigerant, by the liquid refrigerant. And after this compressor, here up to the expansion wall, this portion is at the higher pressure. Okay, so because of this pressure difference generated by this compressor and this expansion wall, this liquid vapor, saturated vapor, then superheated vapor, then saturated liquid, so there's a continuous flow of refrigerant in the various form. So this process results the adiabatic flash evaporation and the auto refrigeration of a portion of the liquid. So this adiabatic flash evaporation process is the isenthalpic or at the constant enthalpy. So in this way, the refrigerant is flow in the this closed tube, and this compressor, it will generate the high pressure. This expansion valve, it reduces the low pressure. Okay, and in this low pressure, the liquid in the evaporator, so it will absorb the latent heat for conversion of liquid to vapor. Okay, so here it will absorb the latent heat from the surrounding, and this low pressure vapor, saturated vapor, is compressed by the compressor, so that the pressure of this vapor, it is increased, and the temperature of this saturated vapor, it is increased to the superheated vapor. Okay, so by increasing the pressure. So with this increase in the pressure, the temperature of this vapor, it is increased, and when it passes through the condenser, so this high temperature is dissipated to the surrounding or atmosphere through this condenser. So heat is dissipated to the environment. Okay, so that surrounding environment, it is get heated. So in the condenser, the heat is dissipated. Again, because of this rejection of this heat from the vapor, so it changes its state from vapor to liquid, and this liquid is passes through this expansion valve, again from higher pressure to the lower pressure. So this system or this operation is called as a vapor compression refrigeration system. This vapor is compressed with the help of this compressor, where the electrical energy is utilized in the work done or as a work input. Okay. So this cycle, again it is explained here. The vapor compression cycle is used in the most household refrigerators, as well as in many large commercial and industrial refrigeration system. In this method, a circulating refrigerant such as freon enters the compressor as a vapor, during which it is compressed at the constant entropy, and exits the compressor as a vapor at the higher temperature. This heated vapor travels through the condenser, which cools the vapor and condenses it into a liquid by removing additional heat at constant temperature and the pressure. So this common type of domestic refrigerator have a cabinet shaped with compressor, motor fan assembly, the condenser and the receiver fitted in their basement. Okay, so in the domestic refrigerator, there is a closed cabinet, then there is a compressor, there is a condenser at the back side, so which is a black tube, black colored tube. The expansion valve and the evaporator coils are exposed in the storage cabinet. Okay, so this expansion valve and evaporator, so it is mounted inside the cabinet of the refrigerator or the storage, where we have to keep the food, with the help of piping carrying the liquid refrigerant passing through the body. The heat of the bodies to be cooled is carried to the evaporator coils by means of air trapped in the cabinet. The refrigerator used may be the open compressor type, or hermetically sealed compressor type, or the absorption type. Now we'll see the working of this vapor compression system with the help of the figures of the refrigerator. Okay, so this dotted portion is a refrigerator cabinet, and this evaporator tubing or coil, it is placed in this refrigerator unit. Okay, so this is an expansion valve in the form of capillary tube. Then this is a condenser mounted at the backside of the refrigerator, and this is a compressor mounted at the base of the refrigerator cabinet at the backside. Okay. The low pressure refrigerant vapor coming out of the evaporator flows into the compressor. Okay. So when the refrigerant, it is moving through this evaporator tube, so it will absorb the heat. It will absorb the heat, and this vapor refrigerant at low pressure, it is coming to the compressor. Okay, it is coming to the compressor, or it flows into the compressor. The compressor is driven by a prime mover, electric motor, split phase motor, or capacitor start capacitor run motor is used to drive the compressor. The compressor refrigerant vapor is compressed. So in this compressor, the vapor is compressed. Low pressure vapor from the evaporator, it is compressed to the high pressure. Okay. So this high pressure refrigerant vapor from the compressor is then passed through the condenser. So this high pressure vapor, with the increase of the pressure, the temperature of this vapor, it is increased to say 55 degrees centigrade. And because of this compression, because of the high pressure, the temperature of this vapor, it is increased to 55 degrees centigrade. Okay, and normally the atmosphere or the surrounding temperature is 40 degree centigrade. Okay, so depending on the various weather condition, it may be of 40 degree or 35 degree or say 25 degree in the winter. Okay, so depending on the area, depending on the season, the atmospheric temperature, it is less than the compressed vapor temperature. Okay, so here in this condenser, this 55 degree centigrade temperature of this vapor, it is dissipated to the atmosphere. It is dissipated to the atmosphere. And on this condenser coil, generally the cooled air is flowing through this capillary at the backside, and when this air come into the contact with this condenser, so the temperature of this air, it is increased and it moves in the upward direction. Because the density of air, it is decreases, so it moves in the upward direction on this condenser. The refrigerant gives out the heat it had taken in the evaporator. Okay, so this heat absorbed by the evaporator from this evaporator, so it is increased to 55 degree, and this heat is dissipated to the surrounding at the condenser. The heat equivalent of work done on it, W, the compressor. Okay, so the compressor, for this work done, the electrical energy, it is utilized. The heat is carried by the condenser medium, which may be air or water. Okay, So this is the tube, and this is the tube used in the condenser, and generally it has the mounted on the backside of the refrigerator. Okay, and the air is passing from this downward to the upward. Okay, so this high pressure liquid refrigerant then enters in the expansion valve. Okay, so in this condenser, when the heat from this vapor it is dissipated to the atmosphere, so the vapor it is converted into the liquid form. It is converted into the liquid form, and this high pressure liquid refrigerant it then enters into the expansion valve. Okay, so here the refrigerant is at high pressure and in the liquid form, then it is passed through this capillary tube to the evaporator. Okay, so in this expansion valve in the condenser, a small capillary of the diameter of say 5 mm or 7 mm, this capillary hollow tube it is there in the condenser, and it expands to say 10 mm or 12 mm, 15 mm diameter of this tube. So naturally, because of this diameter in the expansion wall or in the capillary tube, this high pressure it is converted into the low pressure by this capillary tube or by this expansion wall. So this wall allows the high pressure liquid refrigerant to flow at a controlled rate into the evaporator. Okay, while passing through this wall, the liquid partially evaporates. Okay, so when this liquid is passing through this expansion wall, so it starts evaporating because of the pressure difference in the across this expansion wall. So most of the refrigerant is vaporized only in the evaporator at low pressure. Okay, so here the temperature is 7 degrees centigrade, and for the vaporization at the 25 degrees centigrade of the refrigerant, so it converts or it absorbs the heat, and to convert this liquid in refrigerant into the vapor refrigerant, so it is passing through this refrigerant cabinet, and after that it is passing through this deep freezer where the temperature is at the minus degree centigrade. Okay, and it will absorb the heat for the vaporization from this refrigerator cabinet or from the evaporator or the freezer. So thus the refrigerating effect N is obtained, and then the low pressure refrigerant enters the compressor and the cycle is repeated. Okay, so in this way the compressor, high pressure vapor, then condenser, here the heat is dissipated to the surrounding, the vapor refrigerant it is converted into the liquid refrigerant, then it passes through this expansion wall, this liquid is converted into the vapor, low pressure vapor, again this low pressure vapor it is passing through this compressor, and the cycle is repeated. So this is the operation of this vapor compression system in the refrigerator. Now we'll discuss about the construction of the refrigerator. Usually hermetically sealed type refrigerator it is used. Okay, hermetically sealed. So this capillary tube it is inserted in this cabinet. It is used in this freezer section. Okay, so you can see here, this blue one is the capillary tube used in the freezer part. This is as a condenser at the back side. The compressor placed at the basement of this compressor. Here there is a temperature control knob is there. So the main advantages are that the problem of gas leakage is minimized. So this refrigerant in the form of liquid, in the form of vapor, it is flowing through this totally hermetically sealed capillary copper tubes and the compressor. So which avoids the leakage of gas is minimized, and there is no moving parts extend through the sealed housing. It has relatively silent operation and it does not require any maintenance. Okay. So there is no moving part. So naturally there is no noise. Operation is silent and the maintenance is less. In open type compressor, the motor drives the compressor using pulley and belt arrangement. Okay, so which is used in the large size of refrigerator or in the commercial refrigerators. Okay, so this is employed in the large commercial refrigerators. So refrigeration is not only provided with the double-walled cabinet packed with the material having high thermal insulation. Okay. So the inside temperature is less than the atmospheric temperature. So there should be a thermal insulation to avoid the flow of heat from higher temperature to the lower temperature. Okay, so for that purpose the double wall cabinet it is provided. Okay, so at the outer side the sheet metal it is used, and at the inner side the PVC cabinet it is used, and between these double wall the thermal insulation like fiberglass, cork or polyurethane foam or expanded rubber it is used. Okay, so these are the thermal insulator. These are the thermal insulator and they are placed in the double wall. So all round the inside of door flap soft rubber seal is used which makes the cabinet airtight. So on the door this soft flap type rubber it is used when the door is closed. Okay, so this rubber is solve the purpose of airtight. Okay, so it will not allow the flow of air from inside to outside or from outside to inside. Okay, so this rubber it provides the airtight cabinet. So also the door provides with automatic closing mechanism. Okay, automatic closing mechanism. When the door is kept open, so this with the help of this automatic closing mechanism, and in this mechanism the door hinges they are provided in such a way that when the door is kept open, so these are the hinges and these are the support. These hinges they are engaged in this part. Okay, so this door it will close automatically. It closed automatically. Okay, so with help of these hinges, and it comes to the closing position due to the gravity, and as it approaches the closing position it is attracted by this magnetic strip. It is attracted by the magnetic strip, so that at the end the force is generated by this magnet, so that the door is closed tightly, okay, and the sealing rubber ring, and thus the door is closed with the snap action, okay. So with this automatic door closing mechanism or these door hinges, uh, at the front side, the gravitational adjustment screw they are provided, okay, so that from the front side, so slightly it is tilted in the upward direction, okay. All this is done to prevent the leakage of atmospheric heat inside the refrigerator, okay. So the door, this rubber gasket, the hinges, they are also playing the important role to avoid the leakage of this atmospheric heat, okay. Now we discuss the electrical circuit of this refrigerator, okay. In this electrical circuit, the thermostat switch is there, so which will sense the temperature inside the thermostat, or we can set the temperature with the help of knob or with the help of dial, okay. Then door switch, door lamp is there. So at the night when we open the refrigerator, so lamp is provided to get the illumination inside the refrigerator. Then there is a thermal overload release is there for the protection of this motor, compressor motor. These single phase motors, they are not self-starting. To make the self-starting, this starting electromagnetic relay, it is provided, okay, so that it will provide the supply for the starting winding or the auxiliary winding, okay, so that the motor is split phase or the phase difference in the motor, it is generated by the starting electromagnetic relay, okay. And this is a compressor motor, single phase compressor motor. So in this diagram, so this is a split phase single phase induction motor, it is shown here, okay. So the refrigerator is provided with the door push switch, which closes on opening of the refrigerator and puts the lamp on, okay. So on the refrigerator, when the door, it is in the closed position, so this force or door force, it is acted on this door lamp switch, and this switch is in the open position. When we open the door, so this force is removed from this door lamp switch, and because of the spring force, in the switch, this switch closes and it will complete the path through this door lamp, and the door lamp is on, okay. So this is the function of this door lamp switch and the door lamp. So split phase single phase induction motor is used in the sealed unit of refrigerator or the compressor. So this is the split phase induction motor. Electromagnetic relay is provided to connect the auxiliary winding on the start and disconnect it when the motor picks up the speed, okay. So when the motor, it starts from zero or from its steady state condition, this electromagnetic relay or the current is drawn by this main winding, okay. Now see, the current, it is flowing from this phase through this thermostat, through this overload relay, and through the coil of this electromagnetic relay and through this main winding. Okay, so initially to start the motor from zero position, so this main winding, it draws more current. It draws more current, and because of this more current drawn by the electromagnetic relay coil or flowing through this relay coil, so it is get electromagnet is formed and it close this switch. It close this switch, and when it close this switch, so this supply, it is also passing through this auxiliary winding, through this auxiliary winding. Okay, and or the running winding. So these two winding, they are placed at the 90 degree to each other, and the phase difference, it is generated, and this auxiliary winding, it helps to start this compressor motor or to start this split phase single phase induction motor. Okay, so in this way, when the motor starts and it picks up the speed up to the 80%, so the current through this main winding, it reduces to its normal rated current. Okay, and as the magnitude of current through this coil, it reduces, the electromagnetism is vanished in this electromagnetic relay, and this electromagnetic effect vanishes, so this contact is open and the auxiliary winding is disconnected at the rated speed. Okay, so this is the function of this electromagnetic relay. Okay, then the thermal overload relay or release is provided to protect the motor from damage against the overflow or the overcurrent. Okay, if there is any fault, so this motor, it draws more current than its rated value. So this thermal overload release, it protects the motor to draw over current. Okay, so in this thermal overload relay, the bimetal strips, they are provided. When it draw more current, so this bimetal strip, they open, they bend and they open the contact, so that the supply for this induction motor, split phase induction motor, it is get disconnected during the overcurrent or during the fault or during the abnormal operation of this motor. The thermostat switch is provided to control the temperature inside the refrigerator. Okay, so based on the temperature setting, this thermostat, it sends the temperature and it will give the on and off signal for this compressor. So the temperature inside the refrigerator can be adjusted by means of the temperature control screw. Okay, so on this thermostat, so this is a temperature control screw. Okay, so here the temperature control screw, it is provided, and we are setting the temperature, means greater the distance between the contact, greater will be the temperature inside the refrigerator and vice versa. Okay, here we can see this is a 5 number, this screw, and this 4 number metal strip is there. Okay, so when this gas, thermophile in this tube, it is get expanded based on the temperature inside the deep freezer or inside the refrigerator. So this thermophile, it is get evaporated and it is moving through this coil. It is moving through this capillary tube and it closes this contact, and it closes this contact. Okay, means when it closes the contact, it will pass the supply to the motor. Okay, it pass to the supply to the motor. Okay, and जैसे आपका अंदर का टेम्परेचर कूल हो जाएगा, when the temperature is cool, when the compressor is on, so this gas again it is get cooled down. Okay, it is get cooled down. So this gap again it opens. It opens. So it stops the supply for the compressor. Okay. Again, the temperature inside the refrigerator it increases. This thermophile it vaporizes and it closes. So how much temperature should require inside the refrigerator, that is set by this 5 number, by this screw or by this knob on the thermostat. Okay. To protect the motor against under voltage, use of automatic voltage regulator is essential, since in case of fall in the applied voltage, motor will draw heavy current to develop the required torque. Okay. So when the voltage level than the rated voltage of this motor it reduces or it decreases, or the voltage level is reduces, so to maintain the rated output, shaft output or the torque or the HP output at the shaft, okay, so the motor it will draw more current, it will draw more current or heavy current from the supply side. Okay, and during this heavy current drawn in the under voltage condition, so we need to protect the motor. If the motor it is drawing heavy current, so the insulation of the winding it starts aging and the winding performance it decreases. Okay, and by the aging, so there is a damage to the winding. Okay, so to avoid the heavy current, so this thermal overload relay is used. Okay, this thermal overload relay is used to protect the motor from drawing the heavy current during under voltage condition, and it eventually stops the burning of the compressor motor. So starting relay is connected in series with the running winding of the motor. So now we see how this relay it works, how this thermal overload relay it works, the function of this thermostat switch. Now we'll see the arrangement. So this starting relay it is connected in series with the running winding. It is connected in series with the running winding. Okay, and the contact of this relay they are connected to the auxiliary winding. Okay, so when supply is on, the high current flows in this motor starting winding and it starts, and also the relay contact closes and connect the starting capacitor. Now in nowadays the capacitor starting motors they are used. Okay, because the this split phase capacitors they are having low power factor, so the starting capacitor are used in the starting winding. As the motor gradually reaches the normal speed, the current in the running winding decreases and making the relay open, thus disconnecting the supply to the starting winding of the motor. Okay, the overload protector protects the motor against the excessive overload. So all these components, thermostat switch, thermal overload release and the starting electromechanical relay, it is connected in the series. It is connected in the series. So this is the thermal overload relay used in the refrigerator. Okay, so this relay basically has the bimetallic disc or bimetallic strips are there. Okay, so when the excessive current flows in the motor, so this current also flowing through this bimetallic disc, and the temperature of this bimetallic disc increases, and they open the circuit automatically to stop the motor. Okay, so bimetallic strip means they are having two different metals, and these two different metals are having the different temperature coefficient, so that these strips, they start bending and they disconnect the current path or supply to the single phase motor. So the function of this thermostat is to monitor the refrigerator temperature and start or stop the motor, so that the compressor is turned on or turned off. So when the refrigerator temperature increases, the contacts of the thermostat close. Okay, means the thermophile in the small capillary of this thermostat, it get vaporizes, and the bellow, it expands and it closes the contact, so that it starts the compressor, and the cooling effect inside the refrigerator, it is generated. So when the temperature decreases, the contact open, means this thermophile in the form of vaporize, it converted into the liquid, so that the bellow, it is get contracted, and these close contacts, they open, and the supply to this compressor motor, it is stops. So here the new relay or new starter called as a PTC starter, it is used in nowadays in the refrigerator. Okay, instead of using that electromechanical relay, this PTC means positive temperature coefficient starter, it is used. Okay, so it is a kind of semi conductor material which has the positive temperature coefficient, means as the temperature increases, the resistance of this material, it is increases. Okay, so these are the images of this PTC starter used in the relay. Okay, so before starting the function of this PTC relay, so here there is a single phase supply. So phase, it is connected through this overload protector to the common of this starting winding and the main winding. So this main winding, it is connected to the PTC starter and to the neutral. Then this starting winding, it is connected through this 4 and 5 terminal through this positive temperature coefficient material through this starting capacitor, and this starting winding is connected through this terminal number 2, 5 2, through this running capacitor to the neutral. Okay, now we'll see how this relay or how this PTC starter it works. Okay, now in this PTC starter, so this relay or the temperature uh, is generated, temperature it is generated, and based on this temperature generated, the resistance of this element it is increased. The resistance of this element it is increased, and it allows or it opposes the flow of current through it. Okay. So the BaTiO3, barium titanium, this ferroelectric ceramic material is used in this PTC starter. Okay. First we'll see the composition. So PTC means positive temperature coefficient, is no contact semiconductor starting device. There is no contact. Okay, like electromagnetic relay. So there is a make and break contact is there. So here there is no such a type of contact is there. So which uses the ceramic material consisting of BaTiO3, barium titanate, barium titanate. Okay, so this is a semiconductor material is there. Okay, so when the higher temperature is there, so the higher the resistance value of this BaTiO3 or barium titanate. Okay, so these features are used as a starting device for the motor. Okay, then the role of this PTC starter. The PTC is attached to the sealed compressor and is used for the starting the motor. Okay, so when the motor is in the off condition, okay, so the resistance of this barium titanate is less. Okay, it is less, so that the current is passing through this main winding, as well as it is a passing through this starting winding, through this minimum resistance of PTC element, through this capacitor, starting capacitor. Okay, so that this capacitor is generating the phase difference between starting winding and main winding, and the motor it is started. So this current it is flowing through this starting winding, through this PTC element. As the current is flowing through this PTC element, the temperature or the heat is generated because of the flow of current through this element. As the temperature increases, so with this increase in the temperature, the resistance of this PTC element it is increases, and it stops the flow of current through this starting capacitor, okay, and the current through this starting winding is start flowing through this running capacitor. Okay, and this running capacitor it serves the purpose of improving the power factor of the refrigerator. Okay, so in this way this PTC starter it works. Okay, so there is no moving part. Okay, so the compressor is a single phase induction motor. During the starting operation, the PTC allows current flow to both the start winding and the main winding. Okay, so when the current is flowing through this PTC, so the resistance it is increases and it stops the flow of current through it. It requires approximately 5 minutes for the pressure to equalize before the compressor can restart. Okay, so during this time The PTC device generates heat during the operation and therefore it must be allowed to cool before the compressor can restart. Okay. So based on the pressure difference or pressure equalization between the compressor low side, compressor low pressure and high pressure, so it will take 5 minutes to equalize the pressure. Okay, and within this 5 minutes, so your compressor is in the off condition, and within this 5 minutes, so your PTC, it is cooled down and it is ready to restart the next operation based on the command received from the thermostat. Okay. So in the refrigerators, we have to take some precautions. The main precautions to be taken is that the very hot things should not be put in the refrigerator. Okay. So for this, when we keep these hot things in the refrigerator, so it is done, it quickly evaporate the refrigerant in the evaporator coil, producing a large vapor pressure resulting in increase in the duty of the compressor. Okay, so the refrigerant, it is vaporized. For that, it will take the heat from this evaporator or from this refrigerator, and it results the increase in the duty of the compressor, so that the compressor is run for the longer duration. Compressor is run for the longer duration to maintain the set temperature inside the evaporator box. And as such, motor has to work for longer duration in order to bring down the temperature in the freezer compartment. Okay. So to minimize the temperature, so motor is run for the longer duration and it may damage the motor which is short time rotor. Okay. So generally the motor used in the compressor, it is a short duty. Okay, or intermittent duty, means for few minutes it is a turn on, for few minutes it is a turn off. Okay, so that is called as a short time rated. But when we keep these hot things in the refrigerator, so to cool down this, it will take a long time and there are chances of damage to the motor. Okay, so also moisture released from this hot thing will freeze around the freezer compartment, which has to be defrost. Okay, again for to this defrost, the heater is turned on. Okay, so for that, more electrical energy, it is drawn from the supply side. So good practicing measures to operate this fridge at the energy efficient level. Okay, so for that, open the refrigeration door fewest time possible. Okay, first thing, cool the hot food to the room temperature and then keep these things or food inside the refrigerator. Clean the condenser coil behind the refrigerator. Okay, so because when the dust is accumulated on this condenser, so dust is a bad conductor of heat. Okay, and it will not allow to dissipate the heat from the condenser. Okay, so the clean the condenser frequently. Check the door gasket for air leakage. Okay, for air tightness. So the atmospheric air should not enter into the refrigerator. So check the door gasket. avoid unnecessary low temperature settings. Okay, during winter season, during rainy season, so there is no need for the low temperature. So in that case, so we can set the proper temperature. Okay, avoid the excessive ice building. Okay, so in summer season, the ice is required. Okay, so excessive ice should not be built up in the refrigerator. Okay, so when you require the ice, only for that time period you can prepare the ice. Use the power saver switch. Okay, and do not block the airflow passage and to form the condenser coil. Okay, so for that the refrigerator should be kept at least 1 and 1 1/2 feet away from the wall for the free air circulation at the condensers. So thank you for patience listening. Welcome for the next video on the absorption cycle of the refrigerator. Thank you.